I'd like to make a correction to the answers given in the textbook for exercise 21D. It's particularly this question. They draw a graph, and I'll show it afterwards, but I'd like you to follow through my argument first, and we'll explain why I think that they are incorrect in their answer. So let's prepare to get a set of axes. And the vertical axis is the depth, the horizontal axis, time. So let's just go depth. Don't want it to shape on. Depth to time. And to help us discuss it, I'm going to label some various depths. So we've got a depth here, a depth here where significant things happen. So we've got A at the bottom, B, C, and D. Now the descriptions I've had in the answers were fine for describing what this is, but what happens at B and C? Their answer, they seem to treat them as separate graphs, separate parts. But the thing to realise is just below B and just above B, these 2 points, if I put a depth B, let's say what's happening at B here, let's say C is up here, and let's look at what's happening on the other side. So at B, just below it, is the same width as just above it, really tiny. So they must be actually increasing at the same rate. So they go up at B at the same rate. Now, the reason I can draw, actually, let's go back and discuss what line I should be drawing. Nearly everybody agrees with it. Between B and C, the same width, it's a straight sloping line going up. So as it goes in, a constant volume of water across a constant area, it means it's constantly going up by the same amount. So the depth increases at a constant rate. Now what happens at B is just below that, the shape looks pretty much the same and the same width. So it must be doing something like the same direction. And let's do the same thing at C. Either side of C, it's coming up at a constant rate as we get to C, and just the other side, it's pretty much the same size. It's only as you start getting up towards D as the size change significantly. It's only as we get down towards A does that size change particularly. So now we can go back and figure out what's happening at A. Well, at A, very small, it rises quickly. This bit, I don't have a problem with what they drew in the graph. But it's as it grows up from A, it slows down in the rate it grows, because as you get more width, it takes more water coming in to make the depth go up. And that keeps happening until we get to B. And at B, it then goes at this same length. So either side of here, it should be doing the same thing, because the two are pretty much the same. There is no jump. At the top end, we've got the same thing going on. What happens is it starts getting smaller, so as we get up towards D, it does the opposite. Now it does it a lot quicker than it did in A. So the time taken for it to get to D is going to be a lot shorter and therefore a lot steeper to get to D. This time here being shorter probably won't get you the marks. But the important part is at C and B, the cross section looks the same either side. So therefore the rate at which it flows should be the same at either side. Just try and give you a counterpoint to that, and I haven't got the screen ready yet, so I'm just going to get to it. So the second question, question B, is actually a very good example of how you get not the same slope either side of the point. So let's just set this up and do the same thing. Let's go to the situation, draw the graph, and hopefully you'll realise why I consider their answer quite poor, actually. And then, so we've got depth, and we got T. I'm sorry, that should be the point D, and this is depth. So I'll label it properly. So let's let it go through this one. Starts off quite wide. That means it rises slowly. So we'll label the point. We've got an A, we've got a B, we've got a C. So A, very big across, so it rises very slowly. And then when we get to the point B, what happens is we go from rising quite slowly, it suddenly jumps in the width. The width changes massively, quickly. That means the rate at which it rises, it goes up, changes quickly. That's what leads to this having an angle. Which way does the angle turn? Well, we're going from slowly rising to quickly rising. So quickly rising leads to a very steep point to C. And that's what leads to that having a sharp turn, is the sudden change in depth, width here. At that point B, it suddenly jumped in. This one, there's no sudden change in the actual width of that line. So that means that they're not actually going to change very much. Okay, so that's my rebuttal for our question number 1, and you might understand why. When I've seen that answer, I've given some people cause for concern about, did you actually do the work? So you need to have another look at this.